All right, let's go over some of these basic rules of exponents. Hopefully you'll remember them. They're pretty elementary at the start, okay? We know that an exponent is just an abbreviated way of writing a longhand multiplication. So x cubed is x times x times x, okay? When multiplying expressions with exponents, we add the exponents, okay? X cubed times x squared is x to the fifth, okay? And it doesn't really matter, okay, um, what the nature of the exponents are. We're going to add them, whether they're whole numbers, fractions, or even more algebraic type expressions, okay? Uh, and of course, we know that when we have terms down here, 3x squared times negative 8x to the fifth is negative 24x to the seventh. That's all very elementary. Here's our general rule. Ax to the p times bx to the n is a times b x to the p plus n. Multiply the coefficients, whatever they are, add the exponents, regardless of whether they are whole numbers, okay, fractions, negatives, okay, whatever they are, even if there are other variables, we're just going to add them, okay? Powers of monomial is something when you have a monomial to a power like this. Again, this is a shorthand notation. You should be able to jump directly from this expression to the 16x to the 12th. We know that the coefficient is raised to the outside power, 2 to the 4th, 16, and multiply the insides outside powers. Here's our basic rule down here. AXP to the power n is a to the power n x to the power p times n, okay? Again, bear in mind, this general rule does not specify the nature of the exponents, whether they're uh, integer, positive or negative, rational, meaning they could be fractions, even more abstract things like exponents of pi or anything of that sort. We'll take a look at examples like this. This is some very common type problems that you probably saw with elementary algebra, okay? And you should be able to follow this through without any real difficulty, okay? A division is, of course, the opposite of multiplication, so the opposite rules apply. So on the multiplication, we added the exponents. On the division, we divide the exponents. We subtract the exponents and divide the coefficients. Example, okay, is stated here, okay. Negative 24x to the 6th divided by 8x to the 4th. Negative 24 divided by 8, negative 3, x to the 6th divided by x to the 4th, x to the 2nd, okay? This gives us the potential of having negative exponents. So invariably x cubed over x to the 5th by our rule is x to the 3 minus 5, which is x to the negative 2, okay? So the generalized rule there, x to the negative p is the same as 1 over x to the positive p. Okay? All right. So now let's look at some things a little bit more exciting in terms of exponents, okay? And develop some rules from there. Negative exponents, like we just said, x to the negative a is 1 over x to the positive a. So 3 to the negative second is 1 over 3 squared, or 1/9. 1 over x to the negative second is x to the second. You should be able to reason that out, okay? 1 divided by x to the negative second, okay, is 1 divided by x to the negative second, or 1 divided by 1 over x squared, which is 1 times x squared over itself. So basically, negative exponents imply that they're in the wrong place, and you can put them if they're in the denominator as negative, they come up as a positive in the numerator. Okay, so we should be able to simplify expressions like this. Without negative exponents, that rewrites as y over x cubed. This we can simplify to what, x to the 9th power. You should see that, okay? We should be able to simplify this to 1a to the a to the 1st power times a, which is a cubed, okay? All right. You need to know all those powers, the first you know, all your perfect squares, at least the first 20, 25. You need to know all these powers of 10 up to, you know, 2 to the 10th being 24. They should be, you should have good control of those and recognize them. They're going to come up a lot. You should know the first 5 powers of the first 5 numbers. So again, let me say 2 to the 5th. We knew that that was 32. You know, 3 cubed, but you should know 3 to the 5th, which is 243. And you should have all these down without hesitation, okay? Of course, you should know all powers of 10, okay? Fractional exponents, okay, are roots. Square root 25, otherwise known as 5, is 25 to the 1/2 power. Okay, the cube root of 27 is 27 to the 1/3, which of course becomes 3. The fourth root of 81 is 81 to the 1/4, which is of course the square root of 81 if you want, which simplifies to 3. Okay, fifth root of 32, we should recognize as 2 because you know 2 to the 5th is 32. Okay, generalized expression, the nth root of x is 1 over x to the n. Okay, 25 to the negative 1/2 is 1 over the square root of 25, which becomes 1/5. 243 to the negative 1/5 power, the negative, okay, is only a positional thing. So it's actually 1 over the 5th root of 243. Again, recognizing 243 as 3 to the 5th power, you can easily come right down to 1/3 on that. Okay, these are going to see a lot of. The nth root of x to the p is the radical expression, which translates into an exponential expression, x to the p over n. As in another example, the cube root of x squared is x to the 2/3 power. You should be able to translate back and forth with those. Okay? Going the other direction, 1 over the 5th root of y cubed is y to the negative 3/5 power. Should be able to interpret that, okay? So in general, the other expression, the nth root of x to the p, is otherwise known as the same thing as the nth root of x to the power p. So some examples, the cube root of 27 squared. I don't want to take 27 and square it, but I know I can take the cube root, which is 3, and then square it and turn that into 9. 64 to the 2/3 power is another way of saying, okay, the cube root of 64 squared, which is, of course, the cube root of 64, 4, and then square for 16. These things you want to have a real good handle on. You're going to have a lot of those to work on. 128 to the negative 6/7 power is 1 over 28 to the positive 6/7 power, which is the 7th root of 128, which again, you should recognize that as powers of 2. Most of these higher powers, higher roots are going to be, in almost all cases, powers of 2. So you need to recognize them as stated up there earlier. So again, the negative sends it to a denominator expression, 1 over the 7th root of 128, which is 2 to the 6th power, which is 164. So those are some examples you should be able to follow through with, okay? You'll have some plenty to work on that I'll provide you with.